Hello everybody, my name is Hannah and I'll be showing you my larynx model as well as my vocal folds model today. So I made this and this is the larynx model. So I have all of the specific areas labeled so I can reference them easier and so can you. So to begin at the very top up here, we have the hyoid bone. So I apologize. I also have my notes right here, so I'll be referencing those throughout the video, so that's why I will be looking down. So at the very top, we have the hyoid bone. That is number one. The only bone in the laryngeal framework is the hyoid bone. It's unique because it doesn't articulate with any other bones, and instead it serves as an anchoring structure for the tongue and the larynx. When the hyoid moves, the larynx moves with it, which is crucial for swallowing and pitch changes. Next, we have the thyroid cartilage, is this pink piece right here, labeled number 2, pretty large. This is the largest cartilage in the larynx. This is what forms the Adam's apple, our thyroid notch right here. And its main job is to protect the vocal folds and house the laryngeal structures. The thyroid cartilage also rocks back and forth and stretches and thins the vocal folds to raise and lower pitch. So number 3 is the epiglottis right here. I don't know if you can kind of see that, but this is the epiglottis. It's supposed to be the entire, it's supposed to take up the entire surface area like of the actual whole of the trachea, but just imagine that it does. But this is the epiglottis. This is right behind the hyoid and attached to the thyroid cartilage. That is the epiglottis. Its primary function is airway protection. During swallowing, it folds down to cover the laryngeal inlet, preventing food and liquid from entering the trachea. Okay, so this is the epiglottis right there. Next is the cricoid cartilage right here. It is the yellow part. It makes the ring around the trachea, and I read that it is also attached to the trachea rings with ligaments. So I did kind of draw like some little ligaments right there showing that it's attached. It sits right below the thyroid cartilage. This is the only complete ring of cartilage in the airway. It provides structural support and serves as the base for the arytenoids and several intrinsic muscles. The arytenoid cartilage is right here. They're triangularly shaped. They honestly reminded me of like little cat ears, but they're not. Sitting on top of the posterior cricoid are the paired arytenoid cartilages. These are small but extremely important. They swivel, tilt, and slide to move the vocal folds toward or away from the midline. They are the main controllers of vocal fold adduction and abduction. So these are just 2D, but whenever they are moving, they literally just move however they need to in order to complete the adduction and abduction. So finally, this right here, number 6, is the actual trachea, which is the support for the aforementioned things. So next we have the intrinsic laryngeal muscles. So, I'm sorry, I have dogs. Okay, so the first one is the thyroarytenoid muscle right there. That's it. Which this forms the body of the vocal folds. Their job is to shorten and thicken the vocal folds, lowering pitch and helping with glottal closure during phonation. Next, we have the cricoid thyroid muscle. Seen right there. On the outside, connecting the cricoid and the thyroid, is the cricoid thyroid muscle. This muscle is the main pitch changer, which it contracts. When it contracts, it tilts the thyroid cartilage forward, stretching the vocal folds and increasing pitch. Because the thinner the vocal folds get, the higher the pitch sounds. And this is the muscle that is responsible for that. Then we have the lateral cricoid muscle. I might be butchering these names. And that would be C. We have this in the purple. I did my best to mirror them to both sides the best that I could. As we can see, I did fail. These pull the muscular processes of the arytenoids forward, which rotates the vocal folds inward, and are major adductors and help close the glottis for voicing. Then we have D, which are this right here. The white crossover muscles is the interarytenoid muscles. Running between the arytenoids are these muscles, which is unpaired but connects the paired and arytenoid cartilage. I'm so sorry. I'm so sorry. This muscle is responsible for bringing the arytenoids together at the midline and helps achieve full glottal closure. Finally, we have E, these two muscles right here, which is the posterior cryocarytenoid muscles. Located on the back of the cricoid, these are the only abductors of the vocal folds. When they contract, they rotate the arytenoids laterally and open the airway for breathing. So this is the larynx model. Next, we have the vocal folds. So first, we have the epithelium. This is a thin protective layer, almost like the skin for the vocal folds. It helps keep the folds hydrated and smooth so they can vibrate efficiently. Next, we have the blue layer. We have the superficial lamina propria, also called Rinke space. This layer is soft and gelatinous and is the main contributor to mucosal wave during voicing. Next, we have the intermediate lamina propria, which is the pink layer, the pink sparkly layer. This contains elastic fibers that help the vocal folds stretch and recoil. Then we have the deep layer of lamina propria. This contains dense collagen fibers, giving the fold structure and stability. Together, the intermediate and deep layers make up the vocal ligament, which helps control tension and pitch. Finally, we have the vocalis muscle, which is right here in the black. It forms the body of the vocal fold and adjusts thickness and tension for fine-tuning pitch and loudness. Together, these structures allow the vocal folds to be flexible and strong, supporting efficient vibrations for speech and singing. So this is the vocal fold layer. I'm going to get a good look at it. And I did have my little reference point right here. And then here is the larynx model once again. Okay. Thank you so much for watching.